Children, in today's class from Unit 1, we are going to discuss roasting, calcination and smelting. Now we are going to see roasting. Roasting is one of the oxidation method where the ore is converted into metal oxide. Roasting is generally applied for the conversion of sulfide ores like galena, BBS, zinc blende, ZNS, then copper gland, Cu2S, then copper pyrite, CuFeS2, then iron pyrite, FeS2, like that. So generally roasting is applied for the conversion of sulfide ores into their oxides. Understand, children? Yes. Then generally the process is carried out in the presence of excess of oxygen. Okay. Yes. And the ore is heated. This is the concentrated ore is heated with excess of oxygen below the melting point of the metal in a suitable furnace. Understand, children? So when the sulfide ores are heated with excess of oxygen below the melting point of the metal means the sulfide ore will be converted into their oxides. Understand, children? Yes. So what is roasting? In this method, sulfide ores are converted into their metal oxide. And the concentrated ore is heated with the excess of oxygen in a suitable furnace below the melting point of the metal. Yes, what is roasting? Yes, roasting is generally applied for the conversion of sulfide ores into their oxides, and the concentrated ore is heated in the presence of excess of oxygen in a suitable furnace below the melting point of the metal. Understand? Yes. Why roasting should be carried out below the melting point of the metal means, yes, suppose if the ores melt means the impurities like sulfur and carbonate may mixed and tough to remove them. That's why the roasting is carried out below the melting point of the metals. Understood, children? Now we can see example for roasting. Generally sulfide ores are converted to oxides, isn't it? Okay, yes. For example, galena. The formula of galena is PBS, we know. When galena, yes, what is the name of the BBS? Galena, yes. When the galena ore is heated with excess of oxygen means, yes, it is converted into lead monoxide, PbO. The sulfur in the ore is removed as sulfur dioxide gas. Children. Similarly, when zinc blende, yes, we know is is called as what? Zinc blende. When the zinc blende is heated with oxygen in the presence of, yes, excess of oxygen means the zinc blende will be oxidized to zinc oxide. Yes, it is one of the oxidation method, isn't it? Yes, copper glands, Cu2S. When it is heated with excess of oxygen means it will be oxidized to Cu2O. And the sulfur is removed as sulfur dioxide. Remember, children, yes, roasting is one of the oxidation method. And the sulfide ores are oxidized, yes, by heating the ore in the presence of excess of oxygen in a suitable furnace below the melting point of the metal. Understand? Yes, like that we can write equations for other sulfide ores also. Children, here 3 examples I have given. Yes, if possible means you study and write all the 3 equations, or yes, we can write first 2 equations. Yes. Now we can balance the equation. First one, PBS. When PBS is heated with oxygen means this oxidized to PbO. Yes, balancing. On the reactant side, 1 lead, 1 Pb, and product side also 1 Pb. The next sulfur, 1 sulfur, 1 sulfur, oxygen, 2 oxygen. Yes, here on the product side, totally there are 3 oxygen atoms. Yes. So we should balance the oxygen on reactant side. Product side there are 3 oxygen atoms. If you write 3 on reactant side before O2 means only, we can balance the equation easily. Now 3 2s are 6 oxygen atoms. Whereas on the product side only 3 oxygen atoms. Yes. So we can balance the oxygen before PbO. Okay, yes. So if you write 2, before lead monoxide PbO means now the number of oxygen atom is 4. Okay, whereas the number of lead atom on the product side is 2. Yes, on the reactant side 1. So we should write 2 before PbS. Okay. Now there are 2 sulfur on the reactant side. So write 2. Okay, before SO2. Yes, now lead and sulfur are in the balanced state. Now we can check the balancing of oxygen. 3 2s are 6 oxygen atom. Here 2, then there 4. Okay, so 6 oxygen atom totally. So the balanced equation is 2 PbS plus 3 O2 gives 2 PbO plus 2 SO2. Then second equation, zinc blend. Yes, 1 zinc, then 1 sulfur. Yes, then oxygen atom 2, that side also 3. Okay, yes. So here also if you write 3 before, okay, O2 means only, we can balance the equation easily. Yes, 6 oxygen atom, whereas that side only 3. So we can write 2 before Z and O. Okay, yes, now there are 4 oxygen atom, this side 6. Okay, yes, the number of zinc atom on the product side is 2, whereas on the reactant side 1. So write 2 before Z and S. Now there are 2 sulfur atom, so we should write 2 before SO2 on the product side. Okay, so 2 zinc, then 2 sulfur. Totally, there are 6 oxygen atoms on both sides. Okay, here also the balancing is same. Okay, yes, the next equation. Copper glands. Okay, yes, CU test is called as what? Copper glands. There are 2 copper on reactant side, whereas on the product side also there are 2 copper. Okay, yes, the next is sulfur, 1 sulfur. Okay, oxygen on reactant side 2, on the product side 3. Okay, yes, so here we are writing, if you write, yes, 2. Okay, yes, we can write 2 before. Okay, yes, on the reactant side before O2. Okay, here we can write, yes, now there are 4 oxygen atom, whereas on the product side there are 3 oxygen atom. Okay, ma, yes, so write 2 before Cu2O. Yes, now there are 4 copper, isn't it? Yes, there are 4 copper on product side, whereas on the reactant side only 2 copper. So write 2 before Cu2. Yes, there are 4 copper. Then 2 sulfur on the reactant side, whereas on the product side 1 only. So write 2 before SO2. Now we can balance oxygen atom. There are 4 oxygen atom on the reactant side, on the product side here 2, therefore 6. So totally there are 6 oxygen atoms on product side. So to balance oxygen on reactant side, we should write 3 before O2. Okay, ma. So the balanced equation is 2 Cu2S plus 3 O2 gives 2 Cu2O plus 2 SO2. Children, here the balancing is very simple only. Okay, children, yes. Suppose if the sulfate ores are associated with impurities like arsenic, sulfur and phosphorus, means during roasting these impurities are removed as their volatile oxides. Okay, yes. So for example, during roasting arsenic is removed as arsenic oxide. Okay, it is undergoing oxidation and removed as arsenic oxide. Okay, ma'am. Yes, similarly sulfur is removed as sulfur dioxide gas, and phosphorus is removed as phosphorus pentoxide, P4O10, phosphorus pentoxide. Okay, yes, now we can balance the equation. 1 AS, whereas on the product side 2 AS, so we should write 2 before AS on reactant side. Yes, then there are 3 oxygen atom on product side, that is this side 2 only. So if you write number 3 before O2 means only, we can balance the equation easily. So now there are 6 oxygen atoms, whereas on the product side 3 only. So write 2 before, okay, AS2O3. Yes, now there are 6 oxygen atoms on both sides. There are 4 arsenic on the product side, whereas on the reactant side only 2 arsenic. So we should write, okay, yes, 4 before AS. So cut the number 2 and write 4. Now the equation is in the balanced state. The next one, sulfur. There are 8 sulfur atom. Okay, on the reactant side. So we should write 8 before SO2. Yes, then 8 2s are 16. So here we should write 8. Okay, ma'am. Yes. Then next one, there are 4 phosphorus on the reactant side. Here also 4 phosphorus. Then 10 oxygen atom, this side 2 only. So write 5. Okay, now the equation the balanced state. Okay, children. Yes, along with roasting, you can write these equations also. What is roasting? Give example. One of the important 3 more question. Now we are going to see calcination. Calcination also one of the oxidation method. The term calcination originates from calcite ore. It is the carbonate ore of calcium. The formula is CaCO3. When this ore is heated means it will undergo thermal decomposition and will form quicklime, that is CaO, with an expulsion of carbon dioxide. Okay, children. Yes, generally carbonate ores and hydrated oxide ores are subjected to calcination. Remember, children, carbonate ores and hydrated oxide ores are subjected to calcination. In this process, the ores, okay, that is the concentrated ores are heated strongly in the absence of air. Okay, ma? Yes, during calcination, the concentrated ore is heated strongly in the absence of air. That is the calcination process. Okay, yes, during the calcination of carbonate ore, yes, the ore is converted into its metal oxide with an expulsion of carbon dioxide gas. Similarly, during the calcination of hydrated oxide ores, the water of crystallization or the water of hydration escaped as their vapor. Understand, children? Yes, during the calcination of carbonate ore, the ore is converted into its metal oxide with an expulsion of CO2 gas. During the calcination of hydrated, oxide ore, the water of hydration or the water of crystallization escaped as vapor. Understand, children? And the ore will become its metal oxide. Okay. Similarly, if any organic matter is present in the ore, means the organic matter will also escape as their gas. Okay, that is vapor. Yes, here organic matter refers carbon. Okay, the carbon will be escaped as carbon dioxide gas. Understand, children? Yes, because of the removal of CO2, removal of CO2, the ore will become porous. Understand? Yes, calcination is carried out in the absence of air. Okay, yes. So, what is calcination? It is the process in which the ore is heated strongly in the absence of air. Okay, yes. During the calcination of carbonate ore, carbon dioxide gas is escaped, and the ore will become its a metal oxide. Okay, during the calcination of hydrated oxide ore, the water of hydration escaped as moisture and the ore will become its metal oxide. Okay, if any organic matter is present, means yes, the organic matter will expelled as gas. Okay, yes, because of the removal of that gas, that CO2 gas, the ore will become porous. Understand, children? Even this process can also be carried out with a limited supply of air. Yes, one of the important 3 mark question. Now we can see the example. For example, yes, limestone. What's the formula of limestone? CaCO3. The formula of limestone is CaCO3. When the limestone, it is the carbonate ore of calcium. When it is heated strongly, okay, in the absence of air, means yes, it will undergo oxidation and will be converted into calcium oxide CaO with an expulsion of CO2 gas. Okay, children. Yes. Similarly, the carbonate ore of lead is what is that? Cerussite. Okay, yes, formula PbCO3. Okay, PbCO3 is called as what? Cerussite. When the cerussite ore is heated strongly in the absence of air, means it will be converted into its oxide, that is lead monoxide or lead 2 oxide with an expulsion of CO2 gas. Okay, yes. Similarly, when what is that? Calamine. Okay, calamine, it is the carbonate ore of zinc Z10CO3, isn't it? Okay, when it is heated, means yes, it will be converted into its oxide, zinc oxide, with an expulsion of CO2 gas. Okay, ma? Yes. Now we can balance the equation. children, here all the three equations are self-balanced equation. Yes, first equation, CaCO3, calcium carbonate. Yes, calcium, one calcium, one carbon, then 3 oxygen atom. Okay, similarly the second equation also, one lead, one carbon, 3 oxygen. Okay, then one zinc, one carbon, 3 oxygen atom. Okay, children, all the three equations are self-balanced equation. Okay, yes, then next we can see one more example. When dolomite ore is subjected to calcination means, yes, it will become its corresponding metal oxide. Dolomite ore, it is the, yes, mixture of magnesium carbonate and calcium carbonate and ore of magnesium. Okay, this is carbonate ore of magnesium, dolomite. It is a mixture of magnesium carbonate MgCO3 and calcium carbonate CaCO3. Okay, yes, when it is subjected to calcination means, yes, the ore is undergoing calcination and will form magnesium oxide MgO, yes, and calcium oxide CaO with an expulsion of CO2 gas. Okay, yes. Now we can check the balancing of the equation. The ore is converted into magnesium oxide and calcium oxide. Okay, yes, one magnesium. Then next one calcium, carbon. There are 2 carbon. Yes, here only 1 carbon, so write 2. Okay, ma. Yes. Then next, we can check the balancing of oxygen. On the reactant side 6 oxygen atom. Here 1, 2, then 4. Okay, so 6 oxygen atom. This is the balanced equations. Now we can see the calcination of hydrated oxide ore. Okay, yes, an example for hydrated oxide ore is, yes, limonite and, yes, bauxite. Okay, yes, limonite. Yes, what is the formula of limonite? The last class only we saw limonite is the hydrated ferric oxide, isn't it? Yes, limonite is the hydrated ferric oxide. The formula of limonite is, yes, Fe2O3, isn't it? Yes, Fe2O3 dot 3H2O. Okay, yes, limonite. Okay, yes, when it is subjected to calcination means, yes, it will be converted into its oxide, that is Fe2O3 ferric oxide with an expulsion of water. It is expelled as vapor. Okay, yes, the 3 water molecule will be removed. Okay, similarly bauxite ore. What is the formula of bauxite ore? Yes, Al2. Okay, Al2O3. Yes, n number of H2O. Here n is equal to 2. Okay, yes, let us consider n is equal to 2 here. Al2O3 dot 2 H2O is nothing but, yes, bauxite ore. Okay, so when it is subjected to calcination means it will be, okay, converted into, yes, its oxide, that is alumina, Al2O3 with an expulsion of that moisture. Okay, yes, the 2 water molecule present in it will be removed. Okay, ma. Yes, so here many examples are given. At least you should write, okay, yes, 2 equations. It is an important 3-mark question. Then next we are going to see reduction of metal oxides. Metal oxides can be reduced to crude metal by using a suitable reducing agent like carbon monoxide, hydrogen, aluminium and other reactive metals such as sodium, etc. The choice of reducing agent depends on the nature of the metal. Yes, the choice of reducing agent depends on the nature of the metal. For example, carbon cannot be used as a reducing agent for the reactive metals such as sodium, potassium, aluminium, etc. Yes, carbon cannot be used as a reducing agent for the reactive metals such as sodium, potassium, aluminium, etc. That is, carbon cannot be used as a reducing agent for the reduction of oxides of sodium, potassium, aluminium, because these oxides are very strong and these metals are very reactive. That's the reason. Understand, children? Yes. Similarly, CO cannot be used to reduce oxides such as ZnO, Al2O3. That is, CO cannot be used to reduce oxides such as zinc oxide, alumina, Al2O3. Later, in the same lesson, we study selection of suitable reducing agents by applying a Lingam diagram. Under reduction of metal oxides, we are going to see how metal oxides are reduced to metals by smelting, by carbon, by hydrogen and by aluminium. Now we are going to see smelting. In this method, the concentrated ore is mixed with a flux and a reducing agent. Then the mixture is melted by heating at an elevated temperature in a smelting furnace. Elevated temperature, that is above the melting point of the metal. Yes, in this method, the concentrated ore is mixed with a flux and a reducing agent, and the mixture is melted by heating at an elevated temperature in a smelting furnace. Here, carbon monoxide, aluminium is generally used as a reducing agent. Then, during smelting process, the concentrated ore is mixed with a flux. Now, we can see what is a flux and what is the purpose of adding flux. Flux is a chemical substance that forms an easily fusible slag with gangue. Yes, flux is a chemical substance that forms an easily fusible slag with gangue. That is, to remove the gangue during smelting process, the concentrated ore is mixed with a flux. What is flux? A separate 2-mark question. Yes, a flux is a chemical substance that forms an easily fusible slag with gangue. Once again, we can see the definition of smelting. In this method, the concentrated ore is mixed with a flux and a reducing agent like carbon monoxide or aluminium, and the mixture is melted by heating at an elevated temperature in a smelting furnace. Now we can see the extraction of iron from its hematite ore as an example. For the extraction of iron from hematite ore, the concentrated ore is mixed with limestone and carbon monoxide. Here, carbon monoxide is function as a reducing agent, then limestone is function as a flux. So, when the mixture is heated in a smelting furnace, means the carbon monoxide reduces hematite ore, that is Fe2O3 to iron. Understand, children? Yes, here the carbon monoxide reduces the iron oxide ore, that is the Fe2O3 to iron. Understand? Now we can see the equation for the reduction of iron oxide to iron. Fe2O3 plus CO gives Fe plus CO2. Children, here carbon monoxide is function as a reducing agent. Generally, a substance function as a reducing agent will itself undergo oxidation. So, carbon monoxide CO is oxidized to CO2 during the reduction process. Yes, once again we can see the equation. Fe2O3 plus CO gives Fe plus CO2. The balanced equation for the reduction of iron oxide to iron is Fe2O3 plus 3CO gives 2Fe plus 3CO2. What is smelting? Give an example. An important 3-mark question. In this extraction, the iron oxide ore is treated with limestone. Here the limestone is function as a flux. Okay, yes, here it function as a basic flux. That is, actually limestone CaCO3 is added. During the extraction process, the limestone is undergoing decomposition and decomposed into CaO and CO2. The CaO formed function as a basic flux. Why the iron oxide ore is mixed with a basic flux like limestone means because the gangue silicon dioxide, that is SiO2, associated with the iron oxide ore is acidic in nature. So to remove the acidic gangue, a basic flux, okay, limestone is added. Here the CaO formed function as a basic flux. So if the ore is associated with acidic gangue means it should be treated with a basic flux. Similarly, if the gangue associated with the ore is basic in nature means the ore should be added with an acidic flux. Remember children, all of you. So in this extraction, the basic flux CaO reacts with the acidic gangue SiO2 and remove the gangue as calcium silicate slag. Okay children, the SiO2 is removed as a calcium silicate slag. Yes, so the equation for the formation of slag is CaO plus SiO2 gives CaSiO3. Here the basic flux is CaO and the acidic gangue is SiO2. So the CaO reacts with the SiO2 silicon dioxide and remove that gangue as calcium silicate. The formula of calcium silicate slag is CaSiO3. Once again we can see the equation. CaO plus SiO2 gives CaSiO3. Here all the three substances are in the solid state, so write yes. Then another thing you must indicate, okay, calcium oxide, that is CaO as flux. Okay, that is formed from limestone, isn't it? Yes, for CaO you must write flux, then for SiO2 you must write gangue, then the CaSiO3 should be indicated as slag. You know, flux plus gangue is slag. So what is the equation children? CaO plus SiO2 gives CaSiO3. There is a separate 2 mark question for this one. What is the purpose of adding, or what is the role of limestone in the extraction of iron from hematite ore? Yes, an important 2 mark question.